Have you ever stood on a crowded subway platform and wondered, how did we get here? How did we make this underground world safe? The answer, like many things in history, was written in tragedy. Today, we're going back to the dawn of the electric age, to a time of incredible innovation and unforeseen dangers. We're going to uncover the story of the world's first major electric railway accident, disaster that nobody saw coming, but one that would forever change the way we travel. It's the late 1800s. Cities like London and New York are bursting at the seams. Horse-drawn carriages clog the streets, and the air is thick with smoke from steam-powered locomotives. The future, everyone believed, was electric. The idea of clean, quiet, and fast underground trains was no longer a science fiction dream. It was becoming a reality. In 1890, London opened the City and South London Railway, the world's first deep-level underground electric railway. It was a marvel of modern engineering, a tunnel burrowed deep beneath the city, promising a new era of urban transport. People called it the padded cell because its windowless carriages felt a bit claustrophobic, but it was a sensation. Across the Atlantic, American cities were racing to catch up. Boston, Chicago, and New York were all experimenting with elevated railways and early subway systems. But the real action was happening just outside Chicago, in a place that would become the epicenter of this story. Picture this. It's 1893, and the world's Columbian Exposition, the Chicago World's Fair, is in full swing. This wasn't just any fair. It was a dazzling showcase of the future. Millions of visitors from around the globe flocked to see wonders like the first-ever Ferris wheel, marvel at Nikola Tesla's alternating current system, and taste new treats like Cracker Jack and juicy fruit gum. The fairgrounds themselves were a city within a city, and to move the massive crowds around. The organizers built something truly revolutionary, the intramural railway. This was the first elevated electric railway in the United States. It snaked through the fairgrounds for nearly 3 miles, offering visitors a breathtaking view of the gleaming white city below. The trains were sleek, modern, powered by a third raila, brand new technology that delivered a continuous flow of electricity. It was the star of the show, a symbol of progress, efficiency, and, most importantly, safety. Compared to the noisy, dirty steam engines of the day, these electric trains were seen as the pinnacle of safe, clean travel. But that perception was about to be shattered. The intramural railway was a massive success. Every day, thousands of passengers rode its gleaming cars, managed by a team of motormen and conductors. One of these motormen was a young man named Angus. He was proud of his job, operating the most advanced train in the world. The system used a block signal system, which was supposed to prevent trains from getting too close to each other. When a train entered a block of track, a signal behind it would turn red, telling the next train to stop. It was a simple, seemingly foolproof system. On a hot summer afternoon, things started to go wrong. Train up ahead had a minor mechanical issue and was forced to stop near the Corral Hall station. The block signal behind it dutifully turned red. The next train, following protocol, stopped and waited for the signal to clear. Everything was working as designed. But then came the third train, the one driven by Angus. He saw the red signal and the stopped train ahead. He applied the brakes. But nothing happened. Let's pause here and think about the technology. These weren't the advanced air brakes we have today. They were early electrical and mechanical systems. On that fateful day, Angus's brakes failed completely. He was now piloting a multi-ton electric train with no way to stop it. Panic must have set in. He was bearing down on a stationary train filled with passengers enjoying their day at the fair. He likely sounded the whistle, a desperate warning, but there was nowhere for the people ahead to go. They were trapped on an elevated track, dozens of feet in the air. The collision was catastrophic. Angus's train slammed into the back of the stationary one with incredible force. The rear car of the stopped train was obliterated, splintering into a mess of wood and twisted metal. The impact was so violent that it lifted the car off the tracks and threw passengers onto the tracks in the ground below. Screams filled the air, replacing the cheerful sounds of the fair. It was a scene of absolute chaos and horror. In an instant, the symbol of modern safety had become a death trap. One person was killed instantly, and dozens were severely injured. The world's first major electric railway accident had just occurred, and it happened in the one place designed to showcase a perfect future. The aftermath was immediate and intense. Fairgoers and workers rushed to help, pulling the injured from the wreckage. The fair's emergency services were on the scene quickly, but the damage was done. The news spread like wildfire. How could this happen? Could the most advanced train in the world fail so spectacularly? The investigation began almost immediately, and the focus fell on two things: the brakes and the block signal system. Investigators discovered that the brake failure on Angus's train was due to a faulty electrical contact. A simple, small piece of metal failed to do its job, rendering the entire braking system useless. It was a shocking revelation. Technology was so new that its potential failure points weren't fully understood. But the investigation didn't stop there. It also scrutinized the block signal system. Yes, the signal had worked, but it relied entirely on the motorman being able to see it and stop in time. What if he couldn't? What if his brakes failed? The system had no backup, no automatic way to stop a runaway train. This was the critical flaw. The accident exposed a fatal over-reliance on human action and mechanical perfection. It showed that even with signals, a single point of failure, faulty wire, or a moment of human error could lead to disaster. The intramural railway accident sent shockwaves through the burgeoning electric railway industry. It was a harsh wake-up call. The dream of a perfectly safe electric future had been confronted with a grim reality. Engineers and city planners who were eagerly designing their own subway and elevated systems suddenly had to reconsider everything. Safety could no longer be an assumption. It had to be engineered from the ground up. The most important legacy of this tragedy was the invention of the trip stop or train stop system. This was a revolutionary idea. Instead of just relying on a signal light, a mechanical arm would be connected to the signal. If a train ran a red signal, this arm would physically trip a valve on the train's brake system, bringing it to a halt automatically, whether the motorman reacted or not. It took the element of human error and mechanical failure out of the equation. It was a failsafe. This invention was a direct response to the Chicago accident. The New York City subway system, which opened a decade later in 1904, was one of the first major systems to install trip stops throughout its lines. Boston and other cities quickly followed suit. Today, this very principle, the automatic train stop, is a fundamental safety feature on almost every subway, metro, and railway system in the world. Every time your train slows down automatically as it approaches a station or another train, you are seeing the direct legacy of that terrible day at the 1893 World's Fair. The story doesn't end there. The accident also spurred major improvements in braking technology. Carriage construction moving from wood to steel to prevent splintering and operational protocols. It created a culture of defense and depth in railway safety, meaning multiple layers of protection are needed because any single layer can fail. So, the next time you're on a train, take a moment to think about the invisible systems keeping you safe. Think about the automatic stops, the robust brakes, and the fail-safe signals. They weren't just brilliant ideas someone had in a lab. They were born from tragedy, from the lessons learned when our ambition outpaced our understanding. The story of the first electric train crash is a somber reminder that progress often comes at a price. But the lessons we learn from our failures are what truly build a safer future for everyone. Thank you so much for joining me on this journey back in time. If you found this story fascinating, please hit that like button and subscribe for more deep dives into the hidden history of technology. Let me know in the comments what other historical events you'd like to see covered. Stay curious, and I'll see you in the next video.